Hello, everyone. My name is Katie Emilio, and I'm an engineer in the Professional Development Department at ACI. I'd like to welcome you to today's webinar, Code Requirements for Sampling, Testing, and Inspecting Structural Cast-in-Place Concrete. We're very glad that you could join us. We have Jim Casilio, a Director of Technical Services for Pennsylvania Aggregates and Concrete Association. Jim's experience includes many years as a ready-mix concrete producer, along with experience as a geotechnical engineer and construction materials testing lab manager. Jim is currently a member of ACI 221 Aggregates, ACI 332 Residential Concrete, and current chair of ACI 132 Responsibility and Concrete Construction. We also have with us today Steve Szoke, and Steve is a distinguished code advocacy engineer at ACI. He's a fellow of ACI and a member of International Code Council. Steve is also a staff liaison to ACI's Committee on Codes and Standards, Advocacy and Outreach. And now, in a few short clicks, I will give Steve the screen to go ahead and begin today's presentation. Steve?
Yes, thank you, Katie. ACI, a quick overview of who ACI is, I think is a good introduction to this program. And ACI, we are a professional society. We're a technical educational society dedicated to advancing concrete technology. We're not a trade association, we're not a government agency, nor are we an educational institution. Our committee work is primarily about proper uses of concrete and the development of codes and standards to help safeguard the public. ACI members develop the information. It's not developed by staff, and it consists of a wide variety of groups: architects, contractors, consultants, engineers, educators, material suppliers, lawyers, insurance agents, laboratory technicians, anybody who really has an interest in concrete. We develop more than 400 technical documents, and these include codes, specifications, reports, guides, symposium publications, manuals, and an annual collection of ACI materials, as well as Concrete International magazine. We continue to advance the formats for which we provide our information, and the latest is called 318 Plus, which is an electronic version of our primary design standard, which is referenced in the building code. And that is the electronic version allows the user to look up details, typical details, to see the references online as they're going through the document. So it's a very versatile tool, and encourage you to visit our website, concrete.org, to learn more about that. So along with the education and advancement of technology, it's extremely important to make sure that the testing, sampling, inspection, and installation of concrete is done properly. So ACI has offers certification for those installers, inspectors, and technicians. Plus, to communicate this information other than in written format, we also have a variety of programs through ACI University. The materials support our technical documents, certification, there's monthly webinars, and also a subscription service available. So for today's presentation, all the attendees who stay on for the duration will receive continuing education credit. ACI is a preferred education provider for the International Code Council. And what we're going to address today is the importance of proper concrete sampling, testing, and inspection. Describe some of the basics of the sampling and testing, describe what needs to be inspected. We can't, in 1 hour program, cover every aspect of sampling, testing, and inspection, but we'll give you a quick overview of what's important so you can recognize why personnel need to be properly qualified and to identify appropriate personnel qualifications, because it does fall on the building code official to approve the certified personnel. So with that, I'm going to turn it over to Jim Casilio to start us off with the sampling and testing portion of the program.
Thank you, Steve. I want to talk a little bit about the importance of and the building code requirements for testing concrete properly on a job site. I don't want to just talk about, the details and what is required, what's not required, but I want to talk about the importance of it and maybe a little bit about why we do the testing and what's going on underneath these requirements. One of the most important reasons that we need to test concrete properly, because it is the only major building material that comes to the job site. It's not in its final form, and it's a perishable product. But it also has some very important properties that we need to measure. And we're not just talking about strength. We have high expectations on our concrete, and that means we want it to be durable. It also, its performance is dependent upon what happens to it after it gets on the job. We rely on these folks to place, finish, and hopefully cure concrete properly and professionally. We also rely that these folks who are testing concrete bring that same level of professionalism to testing and sampling the concrete as the finishers do to placing and finish the concrete. What we expect is what we see here in this picture. This gentleman has his act together. He's got proper protective equipment on. He has all the equipment that he needs to do the test properly. And when he's done making his cylinders, he's going to put it in a facility that maintains the curing temperatures, initial cure, while it's on the job site. This is what we expect. This is what is required underneath the building codes. However, there's some times where this system breaks down. Today's concrete is a bit more complex than it was many years ago or a few years ago, but at its heart, it's pretty much the same. 2/3 of it is made from aggregate, fine and coarse aggregate, then lesser volumes of water and our cementitious materials that we put in, and then just a little bit of entrained air to maintain durability in the cold parts of our country. We don't make, transport, or place concrete like we used to. Not too long ago, commercial concrete was specified as a 6-sack mix, 6 sacks or bags of cement per cubic yard. So first question for you today is, and please put this answer into your chat box, want to know how many pounds of cement are really in a bag or a sack of cement. So used to specify 6 sacks of cement for a mix or commercial construction. If you wanted super durability, high durability, you specified a 7-sack mix. Or if it was lesser strength and not exposed, you could go down to a 5-sack mix. But we don't specify mix or place concrete as you see here. It's a bit more complex, and one of the things that make it more complex is our use of supplemental cementitious materials, or SCMs for short. We have an acronym for everything. Here you see them: fly ash, slag, cement, etc. And we use these. Yes, they improve the strength of concrete more or less, some more than others, but we primarily use these to increase durability, reduce permeability, and they also present us with some benefits too. They really resist concrete's ability, really help concrete's ability to resist attacks from sulfates, as well as preventing some unwanted aggregate reactions. So we use them. It gives us durability, it gives us increased performance, but there's an added level of complexity. Another way that we really make things more complex these days is the use of admixtures, and we can do a lot of things with them. Here you see just some of the admixtures that are available to us to put in our concrete, and many of them help us with initial workability properties, but other ones, such as those that inhibit corrosion, reduce shrinkage, or entrain air, are there to provide us long-term durability. And it's not unusual to have sometimes 2, 3, maybe even more of these admixtures in every load of concrete that's delivered to your job site. So with that complexity comes the need that we better be measuring the properties properly once it hits our job. We also ask a whole lot more of our concrete these days than we did in the 6-sack mix days. Sometimes we need higher strength, way higher than we used to ask. Other times we want a really high level of workability so we get a very attractive, pretty durable finished product. And there's other times we're going to be pouring a large industrial floor with minimal joints, and see, we need that floor to perform well underneath the loads of a warehouse that's used 24 hours a day. And then there's other times that maybe we're not too aware about, that there's folks out placing concrete 12 or 1 o'clock at night. So we can open up and drive over at 5 or 6 o'clock in the morning in our morning rush hour. Now, with each of these applications, we're pushing our concrete in divergent different directions. So it only has its particular properties were important to measure at the time it hits the job. But we needed to do all the specific things we wanted to do. At the same time, we needed to be durable and last a long time. Again, we have a lot of expectations on this material that we depend on. So here they are, listed out with their ASTM requirements. These are the 5 steps, the 5 specifications needed to sample and test concrete properly on a commercial construction project. It all begins with sampling, then its temperature, then the ever-present slump test, each one of these with its own ASTM specification. The density test up on the right-hand side, you don't see it too often, and which is kind of curious because it provides us a lot of valuable information, and it is required. The second most important test is measuring the air content, especially in areas of the country where we have freeze and thaw concerns. And the one that's really important, the primary test, is measuring its strength properties. We need to know that concrete meets the building code requirements and the design requirements of what we're expecting. Well, that's pretty much it, right? Well, there's one missing step, and it's this step where this system breaks down most often. And that is, we need to provide proper initial curing for those strength test specimens. And that's a requirement under the ASTM specification and in the building codes that we rely on. Let's look at each one of these real closely for a moment or two. How many times you've been on a job site where a mixer truck pulls in on the job, technician comes to the back, he grabs a wheelbarrow, first thing off, he goes one way to do his test, concrete truck goes the other way to do the concrete placement. Well, that's not proper sampling, although we see it very often. ASTM standards say we got to sample at least from 2 or more portions from the middle of the batch, after 10, but before 90% of it's out. We mix that up. That's our composite sample. We take it to where we're going to do the testing, and then we protect it from the elements while we do our test. Now, the next most often test is the slump test. Now, back in the 6-sack days, this was the primary way of controlling the quality of your concrete, because if you're mixed with standard amount of cement and you control the water content by controlling the slump, you also control the water to cement ratio, which is the primary indicator of concrete strength and concrete durability. Now, because of supplemental cementitious materials and admixtures, that relationship doesn't apply anymore. So we can't use our slump as our primary control on concrete quality or durability, but it has some uses yet. It is probably the first indicator. I can't say it's a measurement. It's really an indicator of workability, and it's a good measurement yet of consistency from batch to batch. Now, toughest part about this test is keeping that slump cone completely still while you're filling it up and then moving it smoothly within the specified time. This is the test that is most influenced by the person conducting the test. My opinion, the second most important test is the air content, and the one that takes the most time in the field to do. You see here on the picture is the 2 type of meters, the pressure meters up on the upper right-hand picture, both type A and B, of which type B is the most common one anymore. You don't see type A hardly at all. And then below that is the volumetric meter, most often known as the roller meter, as you can see this gentleman rolling the roller meter here. Now, on those pressure meters, you have to have those calibrated before they hit the job site, before they do the test. All right, they're a little bit quicker than the roller meter, but they do have an important limitation. They can only be used on aggregates that's relatively dense. So if you're pouring lightweight concrete, for example, can't use the pressure meter, need to use the roller meter. The roller meter can be used on any type of aggregate. However, that also has one limitation. It takes about 15-20 minutes to do that test properly. And hey, we're concrete people, means we have like no patience in the world. So who wants to wait 20 minutes for their air test result? Well, I'm sorry, but that's how long it takes to do that test right. Now, here's the one we don't see that often, even though it's a building code requirement of this test. Whenever you're going to make a set of cylinders, you need to do this test. As you can see, you can use the bottom of the air meter to do that, but it has a very specific strike-off procedure. So you must use a strike-off plate, which covers the entire surface. And we're going to kind of like give that a shave right along top. So we cut that concrete off. We only want to measure exactly what's in that volume of that container. We know the volume of the container ahead of time, so we measure its mass. It's a really easy calculation to determine its density or its unit weight. When we know that number, we can find out two other things really quickly, and they're important. First is you can calculate the air content knowing the unit weight. And I like to use this very often because if I have a pressure meter reading that doesn't kind of go along with the dosage of air and training I'm putting in, or seems kind of odd, the best way I feel to check it is to run the density test and check my air content gravimetric on that. It really can be an important step before I change something on the mix when I want to really know I'm measuring the air properly. But the second most important thing we can get from that number is, once we have our unit weight, is the yield. All right, we can tell exactly how many yards of concrete were in that concrete truck. Now, there's an age-old argument on construction projects. Contractor's pouring concrete, he runs a few yards short. He says, concrete plant shorted me again. Meanwhile, back at the concrete plant, we get a call, send a few more yards of concrete out. Well, we said, oh, that guy doesn't know how to figure his concrete again. So you have this ever-present argument. The only way to solve that argument is to do a unit weight test. Then you go over to the mixer driver and say, give me your printout, show me how many pounds are in that truck. And real easy, within a few seconds, we can determine how many yards of concrete in that job. So we know who's right, who wins that argument. Unfortunately, in our business, I think there's many people who enjoy the argument more than they enjoy the answer. The last test we talk about is temperature, and temperature and strength development of concrete is so temperature dependent. This is the only test where you don't have to use that composite sample on. Standards allow us, as long as we have 3 inches of fresh concrete around that, we can put our thermometer in there and measure that temperature. And here you see on the screen the ACI guide requirements for concrete temperatures, both minimum and maximum, as delivered to the job site. Not maintained, but the first check on temperature is, hey, what's the temperature when it gets to the job site? This is super critical in times of hot weather and in times of cold weather. All right, and the test that's the most important, because we need to know whether this concrete strength meets the building code requirements, and that's making and curing our strength test specimens according to this ASTM standard, which is C31. So we mold them properly, we consolidate them properly, move them immediately into their initial curing, and maintain initial curing, 60 to 80 degrees while they're on the job site, a little tighter spec if they're higher strength, and we protect them from moisture loss till they go to the lab. What happens to them at the lab? Once they arrive at the lab, they're kept in a 100% humidity room, or they're kept in a saturated lime bath until they're ready to be tested. Then they need to be capped. And in the center, you see the steel retaining rings and the neoprene caps. By far, that is the most common method used to cap our cylinders nowadays. Sometimes we still use the sulfur capping compounds that's shown on the lower picture if our specifications. If our cylinders are a different diameter from our rings, that we don't have the right size rings, cylinder might be a little out of round or out of tolerance, or we're really, really concerned, we want exact measurement, super exact measurement on it, we can use a sulfur cap. Once we have our cylinder cap, then we're ready to test them, or we break them. All right, compressor strength test on the top and a flexural strength of beam on the bottom. And if you haven't been to the construction laboratory that's doing the testing on your job, talk to your technician, follow your sample, say, hey, I'd like to come over to the lab, see what happens to them once they get over there. I'm sure they'll be happy to show you around, and you kind of learn a little bit more and see from start to finish what happens with your concrete samples. Now, we got all our testing done. We have our strength test. Time to issue a report. Who does that go to? Building code says that goes to the building code official and the registered design professional. Further back in the building code documents, ACI 318, that comprise the basis of our concrete building code, says that the contractor and the concrete producer, and if requested the owner, also get those test results. Said where the system breaks down, it's on the initial curing. So here are the requirements. Maintain temperature, protect from moisture loss, and free from disturbance. The easiest way to do that is with that self-contained unit you see in the picture on the lower left. Okay, it can heat, it can cool, and most important, it has a min-max thermometer that records the temperature of that. Now, I was always taken back by the argument, well, we can't get these, they're too expensive. Well, the price pales in comparison to the price of in-place concrete or concrete that's delivered to its yard, to a job site, is orders of magnitude more expensive than one of these, and they don't go bad. You can use them from job to job to job. Now, the good news is they have come way down in price from what they used to be just a few years ago. So they're affordable. But even if you don't want to do that version, which is the best, there are easy ways to accomplish keeping these within the requirements that they need to be. The easiest way is to put those cylinders right after they're made, submerge them in water. Why? First of all, we prevent moisture loss. Second, it's much easier to keep that water either in that half a barrel or in that other tub between 60 and 80 than it is the air around the cylinders. But of critical importance is to record the temperature while they're on the job site with a min-max thermometer. Nowadays, there's probes you can stick right in that curing box. You can walk by with your phone and the software is available for no charge. Few clicks, you're seeing the history, what's happening on those cylinders immediately. Why do we want to protect from moisture loss? Here's a slide I used to discuss the importance of curing with finishers. Let's take one batch of concrete, make a bunch of cylinders from it. Let's test it over a year. Some cylinders will just sit on the floor in the lab. Some cylinders will keep moist all the time. The ones that we keep moist all the time break about 8,000 PSI. The ones that we kept on the floor in the lab, about 4,200 PSI. So my point of this slide is I tell the finishers, I says, congratulations, if you don't maintain moisture loss in your concrete, you get exactly 1/2 of what you paid for. Temperature is critical. Let's take another batch of cylinders. We'll test them for a year. The only thing we'll do difference is for their first 28 days of life, we'll keep some at 40 degrees, some at 55, and some at 73 degrees. As you would expect, the cylinders at 55 degrees, they break a little bit higher both earlier and later, same age-wise as the ones at 40 degrees. But interesting on this graph is what happens at 73 degrees. We get strength earlier, higher earlier, but then later on in its life, the strength is less. What this graph shows to me is that just be that different mild change in temperature between 55 and 73. We've changed the fundamental chemistry of that important reaction, concrete hydration, that we all depend on for its strength. We've changed that, infected that reaction just by exposing this concrete to that small temperature change. What happens when we expose concrete cylinders to temperature changes similar to this? That first 24 hours is critical. So let's make a set of cylinders. Only difference we'll make is one will keep at 120 for the first 24 hours, one will keep at 73. Other than that, they're all the same. And at 28 days, we've lost 1,500 PSI, or 25% of its strength. Only difference is temperature for the first 24 hours. Let's look at this on a little milder temperature difference. Let's say 73 to 90. Between 73 and 90, we've lost 600 PSI at 28 days. Why is 600 PSI important? You see on your screen there that Equation 1. Prior to a concrete project being started, the concrete plant submits through the contractor to the licensed design professional his history of performance of his mixes. And he must demonstrate an over-design. And an over-design is a multiplier of the standard deviation of its production, in this case, S. So if you have a concrete plant and your standard deviation is 450 PSI, which is normal range for a good quality control concrete plant, you need to over-design 600 PSI. In other words, if the concrete's supposed to be 4,000, the mix submitted must show an average break of over 4,600. That's the over-design. Licensed design professional reviews that information, sees that it meets the code requirements, sends it back for approval to be used on the job site. Fine, let's go build this. Let's send the concrete out to the job. We send the concrete out to the job site and we let those cylinders go just a little higher than our range, in this case, only up to 90 degrees. We've consumed all the over-design the concrete plant puts in to meet the building code requirements. When that happens, there's issues and serious disputes and serious questions. How often does this happen? Well, I wish I had good news for you to say that it doesn't happen often, but it does, and not just in my state. Last year at this time, members of our association observed 103 construction projects across Pennsylvania, and we observed them passively. We just wanted to document the frequency of improper testing. We didn't want to influence the results. What we found, the problem was at a higher frequency than we even thought. And again, we don't think our state is any different from any other one. Other work has been done similar in other areas of the country. Colorado has a great program that does that. What we found is that proper acceptance testing of concrete was only done 15% of the time. So on 85% of the projects, there was a serious violation of the building code requirements. The temperatures you see there are on cylinders that were cast earlier that day. Underneath that elaborate cardboard and burlap system there on your left, on top of the curing box, are concrete cylinders made that day. This is not just a warm weather problem. Project in central Pennsylvania in January, disputes for months over quality of concrete. The breaks were coming back all over the place. But they said, well, we got a heated curing box, so we don't think that's the issue. I says, okay, do me a favor, right before you put the cylinders in there, grab a picture of a temperature for me. It was 39 degrees. And we saw what happens on the upper side. If we go on the lower side, boy, are we gonna affect the strength of that concrete. So fortunately, with this information in hand, producer got to the construction management team and the problems were resolved. And everything since then broke correctly. Another project over in central Pennsylvania the following winter, the face of the technician has been cut off to protect the guilty. But yeah, just dump a little bit concrete there on the snow, I'll get to it. This is a building code requirement. This is an important, valuable material, and it's being treated all too often in that manner. The second thing is somebody's paying for that testing to be done properly. Are they getting what we need under the building code requirements? Are they getting what they paid for? So how do we ensure, what's our best defense to make sure that we're meeting our building code requirements? First is observe. If you don't see something like this on your job site, way to provide initial curing and temperature monitoring on that, that's a red flag. Look into a little more, see what's happened. You know that it's a building code requirement. The most important step you can make is certification of your technicians. It is a building code requirement. ICC says experienced personnel need to be employed by the testing agency. Fortunately, in ACI 318, the documents that make up the basis of that code say the technicians both in the field and the lab need to be certified. So here is that code. And of course, you've got the code on one side of the page and the commentary on the other. The code in mandatory language. The commentary kind of explains a little further what needs to be done. And it says that the technicians need to be certified according to requirements for ASTM C1077. And the programs that best fit that are the concrete ACI Concrete Field Testing Grade 1 or Concrete Stain Technician program. Now, there's other programs that do a good job of that. Washington State has one, District of Columbia has another one, but they meet the requirements of 1077 that calls for independent third-party monitoring of a written test and independent third-party qualification or verification that that technician can do all the required steps in a very detailed performance part. The testing agencies cannot certify their own personnel and meet these requirements. It must be independent third party. And the best way to do that is with the ACI programs. Your technicians have ACI cards on the job site, you know that they're certified. Here, those programs, they're offered all across the state. Our association is one of 3 that provides them in Pennsylvania. It's been my pleasure to be an examiner instructor on these programs for many years. And I'm here to tell you they work. They work really well. Well, how do I know that? In Pennsylvania, our DOT took an extra step and adopted this certification program for all their technicians doing DOT work. Not a building code requirement, but a DOT project. And it's put in place and it's inspected. And I can't even say it's enforced. It's pretty much mandated and inspected. So the enforcement aspect of it, it's gone because it's expectation. And we have almost no problems in concrete testing quality on our DOT work in Pennsylvania. Complete opposite of the 85% of non-compliance that we measured last year. So if you want some additional information, what we talked about was the subject of the cover story of ACI's Concrete International magazine in 2019. Great article by Karthik Obla of NRMCA and Kevin McDonald with Benton Consulting. And our association has put out a one-pager, which is included in your handouts, which gives you some of the stuff, information on making, curing concrete test cylinders. Both articles will refer you to the proper ASTM specification and ACI requirements and help you down the path to understanding these building code requirements better. So with that, that's what I have on concrete testing. And here to talk about the importance of special inspection is Steve Szoke. Steve?
Thank you, Jim. So on special inspection, these requirements are covered in the IBC section 1705. And what's really important about making sure the inspection is right, Jim talked about concrete showing up at the job site, not in its final form. It's a conglomerate of fine and coarse aggregates, water, cementitious materials, and air. And then when we start doing our design of structural elements, we further complicate the system by turning it into a composite material. Now it's concrete that is reinforced with steel rebar. And even the rebar has changed over time. Currently today, there's 4 types of rebar, 4 grades of rebar commonly used in concrete construction: grade 40, 60, 80, and 100. And those grades are an indication of the KSI, or the strength, tensile strength of the rebar. In addition to the steel rebar, now there's also glass fiber reinforced polymer rebar. There's a new ASTM D7957 for that. It works really well in highly corrosive environments. So it's a good way to stop or to improve durability where corrosion or exposure that could cause corrosion occurs with the concrete. And then we also have steel fibers that can be added to the concrete to supplement reinforcement. Table 1705.3 of the IBC lists 14 things that we have to make sure are properly done in the field when structural concrete is being placed. We start with a major concern, which is the reinforcement. So non-prestressed typical reinforcement bars, these are covered, the IBC sends you to chapter 20 of ACI 318, and it has all sorts of requirements for the type of rebar. Everything needs to be deformed except for spirals. What the yield strength needs to be and how it's to be determined. The type of bars that are allowed. There's different types of steel. Anything that's being welded, the deformed bar mats can only be a certain steel if they're being welded. The headed deformed bars, all of these different criteria. So it's really important that whoever's doing the special inspection has a good handle on all of the aspects of the materials and properties and installation on the job site. Chapter 20 goes into further detail when we're looking at strand wire, low relaxation wire, and high strength rebar for pre-stressed concrete. And that pre-stressing includes post-tensioned concrete. So the non-pre-stressed spacing requirements are provided. There's limitations for how many layers, how close the layers can be, what happens when you have multiple layers in columns, pedestals, struts. All of those requirements are spelled out explicitly in ACI 318. In addition, when it's pre-stressed, we also have to look at the center-to-center spacing and any reduced spacing or bundling at the mid-span of the concrete elements. So there's, again, a lot of information, a lot of things that the inspector needs to be knowledgeable about. Even the shapes of the rebar, the standard hooks, the seismic hooks, cross ties, bend diameters, these are all important properties for the concrete. The standard hook is a 90-degree hook. Then we have the 135 hooks, and the high seismic requires a 180-degree hook. So when we're looking at these hooks, it's important that the inspector know that we need to allow these hooks to alternate from one piece of rebar to the next, because there wouldn't be adequate if both ends of the rebar had 135 or any bend greater than 90, they wouldn't be able to install it over the longitudinal rebar. So, but to ensure that there's proper connection and we're properly retaining and holding the rebar in place, we alternate those hooks so that the one side can't slip more than the other, and we hold the rebar in place properly. So this also applies to the ties that are used within concrete elements. We also have to be looking at the splice and splice length. I'll get into that a little bit more. But all of these connections have to be properly formed with the proper laps. If we don't have proper spacing of the ties and the stirrups that are used in the concrete, two things can happen. If the spacing is too far apart, the longitudinal steel, when it's subjected to the ultimate load, can buckle. So we're using those ties and stirrups to hold the longitudinal rebar in place. The other thing that can happen is if they get too close together, then we create a plane for delamination to occur on the cover of the concrete. So we have to make sure that these things are properly placed. There's also splices. The best splice to have is one where the concrete or the rebars are in direct contact with one another and tied together, as shown here. But the code allows you to have a separation in the rebar. or between the rebar, as long as that separation distance doesn't get too big. If that separation distance gets too big, the concrete will start to crack between the pieces of rebar, and we're not going to transfer the stresses from one rebar to the next. The reinforcement has to have the proper mill test reports. It needs to be free of excess rust and mill scale. When we say excess, that means that anything that can be scraped off by a brush with a wire brush is considered excessive, but the rebar can appear rusted on the job site and is still acceptable as long as it doesn't have excessive rust. It cannot have ice, mud, oil, or other deleterious materials on it. And then the bending has to be done properly. No heating of the rebar to bend it. It has to all be bent cold. Welding is another part. The Concrete Reinforcing Steel Institute discourages any welding on the job site. They prefer for any welded elements to be prefabricated before they show up on the job site. But there's two types of welds, and one is the weld down the length of the rebar, and the other is a butt weld. Typically, the butt weld will give better performance than this, even though the welded area here is much greater. Then we have to look at anchors. The importance of getting anchors done properly, it has increased because of some problems that were being experienced in the field. So provisions are now in ACI 318 to make sure anchors are being properly placed. When we're looking at anchors, we're creating a pull-out area where the concrete will fail. We don't want the anchors to fail. It needs to be designed to have adequate pull-out from the concrete. And what really drove this getting into the code rapidly was the problems that occurred at the Big Dig in Boston, where concrete panels fell in the tunnel. And that was simply because of improper installation of anchors. So ACI 318 requires that the installer be qualified for adhesive anchors, and if they're horizontal or upwardly inclined, then they have to be a certified installer. And I mention these certifications because when it says certified, that means that's something that the building code official needs to be involved with to make sure that those individuals are properly certified or get the information from the approved testing agency that demonstrates that these people are properly certified. So ACI 318 also talks a bit about the mix design and properties, the durability, strength. I'm not going to get into this because Jim already covered that in a great amount of detail. But there's other requirements for placement, material storage. Everything has to be protected from debris and ice or other things that can have a deleterious effect on the performance of the concrete. You do not pour concrete into standing water unless you use a tremie, which is basically a tube that takes the concrete to the bottom of the element where you're pouring it so that you're getting the concrete below the water. No pumping through aluminum. The rate of placement is really important, as well as we have to make sure we avoid segregation. So many of those things Jim was talking about for testing the concrete, like the slump, those help us make sure that the concrete is going to perform properly with the method of placement that's being considered. Then there's additional requirements for shotcrete. These are covered in section 16.5 of ACI 318, and that requires a certified nozzle operator because there's unique things about shotcrete placement that don't apply to conventional concrete placement. For shotcrete, if there's any sags, sloughs, segregation, honeycombing, or sand pockets, the shotcrete needs to be removed and redone. Curing, Jim touched on curing a bit. So again, I'm not going to spend much time on that, but there's a lot that happens with curing. There's a lot of different ways of doing it. There's just spraying water on it. There's chemical curing compounds that can be added. We have to make sure that the concrete in place is properly cured, as well as Jim already stressed, the cylinders are properly cured. And additional requirements for curing shotcrete. When we get to pre-stressing and post-tensioning, there's two types. One is unbonded, where the rebar is in tubes through the concrete, or the strands are in tubes through the concrete. And then once the concrete has received sufficient strength, then these are jacked to put tension, to put tension in the rebar, compressing the concrete. The reinforcing strands and rebar, excellent in tension, not so good in compression, but the concrete, excellent in compression, not so good in tension. And then when it's, you can also have the bars stressed before the concrete is poured. That's bonded pre-stressing. So we're stressing the steel, pouring the concrete, and then relaxing the rebar, or taking the forces off the reinforcing strands and allowing all those stresses to compress the concrete. With precast, erection is also important. Some of the toughest loads for a precast panel might actually occur in transport and erection rather than in its final position on the job site. So we have to look at all of these temporary loads and make sure everything is handled according to the construction documents. Diaphragm connections also have special inspection requirements. These need to be done by the registered design professional in seismic design in buildings being built where the seismic design category is C, D, E, or F. So then we also, if there's a problem because the samples that Jim was talking about weren't done properly, those tests and sampling weren't done properly, the curing wasn't right, we get a low strength in the samples and the test specimens. Well, then that requires somebody to come out to core the actual concrete to see what kind of strength tests or strength we have in the concrete. So it's an additional expense, often simply because somebody didn't cure samples properly in the beginning. We also have to make sure we're doing these strength tests properly. There's the laboratory tests that are required by the building code, but there's also field cylinders that could be taken to confirm the strength of the concrete. Because before we can remove forms and go to reshoring, we have to make sure the concrete has adequate strength to support those loads, or we end up with conditions like this. So the inspector qualifications are spelled out quite explicitly in ACI 318. It says it has to be the licensed design professional or somebody working under their direct supervision, or it has to be a qualified inspector. Then when we get to ACI 1613.1.2, if the inspector is doing any inspection on formwork, concrete placement, reinforcement, or embedments, which is most of what they're looking at, the inspectors shall be certified. When it comes to post-installed anchors, the inspectors should be by a qualified inspector or the licensed design professional or a certified inspector. That's for all post-installed anchors. If they're adhesive anchors, then they must be inspected by a certified anchor inspector. So that covers the information that I wanted to present on certifications. As far as a list of qualified certifications, that's also included as a handout, a PDF with this presentation to give you some guidance on acceptable programs that are out there. There are regional programs that are very good. Jim mentioned the Washington State, WABO has programs. The Washington area, or the Washington Association of Certified Engineering Laboratories and outside or in the Washington, D.C. market area has excellent programs. So there's other programs that are out there, but a short list is provided on that handout. So with that, we'll see if we have any questions.
All right. Thanks, Jim and Steve, for the presentation. We do have a couple of questions from our audience for you here today. So our first question is, you covered the requirements for adhesive anchors for installers and inspection. What are the requirements for conventional mechanical anchors?
That's a very good question. The requirements for conventional anchors are covered under the certification programs that are offered for the concrete construction inspector. That inspector is qualified to do those types of anchors.
Our next question is, sometimes technicians say that they don't need to do an air test on non-air entrained concrete. Is that a correct assumption?
No. Whenever you're seeking a set of cylinders for acceptance, it's required to do an air test. And not only because the building code requirement is also important information. If there's air that got into concrete placed in an interior floor slab receiving a power trowel finish, there's a good chance of having a delamination. And when this has occurred, people have gone back and looked at the test results and found that the technician didn't bother taking air test because it takes a few minutes, and that could have been prevented. And many floors have needed to be replaced with a lot of expense and arguments that could have been avoided simply by testing properly in the requirements of the building code.
All right, our next question is, when is special inspection required? And is it required for residential construction? If special inspection is required, are all the tests presented on slide 23 also required?
Well, special inspection is required for all commercial construction being built in accordance with the International Building Code or a code based on the International Building Code that uses Chapter 17, Section 1705. That's explicit in the building code. There are no requirements for residential construction being built to where the code is based on the International Residential Code. But the International Residential Code also allows residential buildings to be built to ACI 318 or the IBC, and under those conditions, that inspection would be required. The inspections would be required, and the people would have to be properly qualified and certified.
Okay, our next question. Should a licensed design professional be present on site to watch some of those fresh property tests, like a slump test or air entrainment?
I don't think it's a requirement as long as the technician is certified. Is it an undesirable thing? Absolutely not.
Following up on that, how would we know if the technicians that are working on our projects have current ACI certification?
ACI's website offers their Verify. In fact, there's an app for your phone where you can just plug in the name of your technician and all of his certifications come right up. And or you could just ask to see his card, which and those cards are good for 5 years, and then they retake the test and they're good for another 5 years. But there's an easy way to check even though their cards may not be present.
Okay. Attendees, in case you have any more questions, we do have a couple more minutes, so please remember in your GoToWebinar toolbar, you are welcome to use that question box to send in a question for us. I do have one more, and then if nothing else comes in, we will wrap for today. So our last question is about freshly made or recently made concrete cylinders that are placed next to your actual concrete placement. And the question is, are the results of cylinders cured in that manner acceptable?
They're not to be used for acceptance testing. The verbiage is very clear in the building codes. The ones that are required for accepting the concrete have to be cured and tested in what we have outlined today. Those are called field cure cylinders, and Steve touched on the importance of them. They can be used as an indicator to tell what the strength is of that actual concrete for formwork removal, for progressing on construction, to see how the concrete has been taken care of. But they're not to be used to say whether your concrete that's delivered to the job site meets the building code requirements. Those are standard cure cylinders.
Steve, perhaps you'd like to address these. These are a little bit on the back end, but there's a couple questions about, does ACI have online courses, and how will they be able to see this webinar presentation again?
Well, I believe we recorded the presentation, so I don't know exactly how we'll make that available. I'm going to dump that back on you, Katie. But
Okay.
let me do the first one, which is if you go to the ACI website, concrete.org, you will find all sorts of training programs, educational programs that ACI offers about certifications, testing, properties of concrete, the basics of concrete. There's a lot of programs there available to you on the website. And also, if you're interested in becoming certified, you can go to we have a section solely devoted to certifications, and you can find out what programs are being offered, where and when, and what entities are offering those programs. As Jim mentioned, there's 3 offering these things in Pennsylvania, with the locations being moved around a bit.
With that, I don't have any further questions. That does conclude our presentation for today. We hope you enjoyed it. Have a wonderful day. Thank you.